Hi everybody and welcome. Today we're going to be talking about pyramids. So honestly pretty similar to the last few videos here, starting off with prisms, then going to cylinders, and now we're moving on to pyramids. So the same idea, the same function of the last few lessons, just again applying it to a new shape. This time, again, we're going to see pyramids. So the big difference here over what we've seen over the last few lectures is that we come to a point this time. So instead of having some parallel bases that are basically mirror images of each other across from each other, in this case, it all comes together at a certain point. So that's going to change things. Going to change a whole bunch of our formulas. Going to make things a little bit trickier for us here today. So a few things to know, generally speaking, about these pyramids. So the point that it comes to is called a vertex. The base is still on the bottom. So the little, whether it's a square, triangle, whatever shape it is, whatever's on the bottom, that's going to be the base. We have something called a slant now, and that's going to be if you lay down in the middle of one of the sides here. I'll make this as small as possible. So for just on this line right here, again, it goes directly through the middle of the triangle. So it's like if you were to lean against a wall. You are obviously taller than what you are leaning against. If you stood up straight, that would be your full height. But the slant is kind of the fact that your feet are a few feet away from something that you're leaning against. That's why it's called the slant. Next, we have height, which this is just directly from the bottom to the top, standing up straight. How tall are you? So in this case, straight up and straight down is 5. So kind of the new terminology here that we're leaning on is quite literally slant. And that's going to be a key vocab word for today and something that we're going to need to make sure we have 100% down in order to do some of the calculating here. But first things first, base area of a pyramid is just the area of the shape directly under the vertex. So in this case, we have a square pyramid. See that this side, this side, this side, this side, they're all the same here. So to find the base area, it's actually a single calculation of just length times width. And in this case, they're both 8. So we'll get 64 meters squared for our base area. See a very similar calculation for the next one, but let's go through the exercise of kind of labeling some of our parts here. So again, this kind of area on the bottom is our base. And this is where it gets a little bit tricky. So right here, we're given this line. So if we're looking at this in terms of the triangle that is the front of our shape here, we're told that 10 is the bottom, and we have sides of 13. So we actually don't know what our slant is. So in red here, we'll see our slants. We don't know that. So this is where kind of the geometry comes into calculating each of our side measures. So what we're going to need to do is break this out into a right triangle. So if we redraw this, just with that piece that we took out of this, we'll still have a side length of 13. We'll know from here to here is going to be exactly half of 10. So 5 from here to here is 5. So we put those two together, we'll still get the 10 that we're looking for. And we don't know our slant. We'll call that x. So Pythagorean theorem time, 5 squared plus x squared equals 13 squared. So we'll have 25 plus x squared equals 169. And then if we subtract 25 from 169, we'll get x squared equals 144. Or in this case, take the root, and x just equals 12. So we've now identified our slant is 12. And that still leaves us trying to solve for the height. And this is where it gets even more difficult. So again, if some of these things are given to us, life is easier, but sometimes we have to do a little bit more work. So let's take a look now back at our original triangle. Well, we know that this right here is our slant. We also know that what we want, and we'll do this in green, is straight up and straight down to the center. What is our height? And the last thing, we'll do this in blue, is we can again make this a triangle. So if we extend it halfway across the base of our triangle, what we're going to see is we can make the shape that we're looking for. Now in this case, we've already calculated our slant, and we're stuck with finding some of our terms. So we don't know our height, we'll call that y, but we actually do know the bottom here. And again, we've taken a chunk half out of the base, which is going to make this half of 10. That base length is 10, so we're going to see that this is, again, here, 5. So awfully familiar, in this case, what we've just done, what we've solved for. And I'm just realizing I wrote down the wrong thing here. So solving for our slant, I should say we've actually solved for our slant and gotten 12. Because that was our answer down here. So my mistake for that. So we know that our yellow line here is 12. All right, so some things that we've filled in, and again to recap, we know that we have 5 here on the bottom, because that is half of 10, or half of our base length. We don't know how tall it is, that's y, and we know if we break this down, we solved for that slant before, that's how we got that answer of 12 right there. So now it's time to do the Pythagorean theorem again. So go through the steps one more time. We'll get 5 squared plus y squared equals 12 squared. 25 plus y squared equals 144. We'll get y squared, subtract 25 from both sides. So 144 minus 25 now is going to give us 119. Then we're going to need to take the root of that to get to our answer. So in this case, the root of 119 equals 10.91. So here we now have just solved for, in green, our height of 10.91 meters. So while we don't necessarily need any of this for the area of our base, all of this is very important if we were to solve for anything else. And we're going to need this in the coming examples. That's why I took the time now to kind of go through. We're going to need to do a whole lot of Pythagorean theorem with these pyramids, especially if they don't give us stuff, because especially on the state test, if you can calculate something, you can guarantee they're not going to give it to you. So that's kind of the idea of going through the steps here today, is to kind of practice that. So again, we solved for the slant, we solved for the height here, and those are two things that we would need. Lastly, let's actually go ahead and do that base area. So our base, in this case, is a square. So again, length times width. So our base area is 100. And this is inches this time. So inches here, inches squared here for that base area. Okay, next up, lateral area of a pyramid. Once more, let's go through our steps. And there actually are some formulas here that are going to make our life a little bit easier. So the lateral area of a regular pyramid, we can define that as L equals 1/2 of P times L, where L is our slant and P is our perimeter. And our lateral area this time is the area of our edges. So it would be like this triangle here is one of our sides. This triangle here is one of our lateral area sides. It's a little bit harder to see from the back, but this kind of blue on the back here, that's another side. And then this red one here, again, a little bit trickier to see on the back, that's another side. So 4 different sides, 4 different triangles for a square pyramid. So kind of what we do here is find the perimeter, find the slant. If we have both of those things, we are in good shape. So first things first, let's go through this pyramid. Our perimeter is all of the sides if we add them up together. So we'll get a perimeter of 32 meters in this case. We already have identified our slant. This is the same pyramid from that last page that we were just looking at. We already have identified our height. So what we need to do now for the lateral area is plug into our formula. Perimeter of 32 and a slant height of 6. So put these things together now. We'll be looking at 32 times 6 times 1/2, or divided by 2. We'll get 96 square meters. Again, for our next pyramid, we already have done quite a bit of this work here. So let's actually go back and remind ourselves of that. So we need our slant height. So from the previous page, we calculated that our slant height was exactly 12 inches. So again, we just did that on the last page, so we're not going to do that work twice. So the slant is 12 inches. So for our next one, perimeter, each of the sides of our base, and if you're unclear on what we mean by perimeter, it's this side, this side, this side, this side, all the edges of the bottom. So we're going to get an answer here of 40 inches, and then we can plug that into our formula. Lateral area is 1/2 times the perimeter times the slant, or 1/2 times 40 times that slant of 12 that we calculated. So in this case, our lateral area is going to be 40 times 12 times 1/2, or divided by 2. So 240 square inches for lateral area. All right, so we've done lateral, we've done base, and again, lateral, we're just shading in all of the sides of our pyramid here. So let's keep going. You can probably predict it because we've done this a few times now. Our total area is, again, base area plus lateral area of each of these pyramids. So basically just go back to those previous pages and add the base and the lateral together. And again, the same pyramids that we've seen. So let's take a look. The base area is 64 and the lateral area is 96 for our first one. So we'll have 64 plus 96 and put those two together here. And that's going to get us 160 square meters for the total area. And then for the next one, go back, same idea. So 240 and 100 exactly. So 100 for the base, 240 for our lateral, put those two together, 340 is our total area. So again, total area, just putting all of the sides together, both the bottom and the sides of our pyramids here. All right, which leaves us with one final thing to do for our video and kind of notes today, which is volume. So the volume of a pyramid is, again, similar to our cylinder. The same concept is the amount that we can fill our pyramid with. And there is a formula for this. It's going to be 1/3 this time times the area of the base times the height. So we have most of these things. It's just time to go together and solve it. So again, capital B means area of the base. So our base area in this case is 64. And to clarify how we got that, again, 8 times 8 for our square on the bottom here is going to get us 64. Next, we just plug it into our formula. So 1/3 times base times height. So 1/3 times 64 times our height of 5. And again, be careful with slant and with just height. So punch this into our calculator, 64 times 5, and then times 1/3 or divided by 3, it's going to give you the same answer as 106 2/3, 106.67 cubic meters for our first one. All right, next, we've done the calculation for this. We just need to look back. What is the height of our second pyramid here? Again, the same shape. We calculated out, we have a height of 10.91 from that first page. we know that we have a base area, in this case, of 10 times 10, or 100 square inches. So volume is still 1/3 base times height. In this case, 1/3 times 100 times our height of 10.91. So 100 times 10.91, and then times 1/3, or you can divide by 3. Again, same difference. Get 363.67 inches cubed is how much we can fit inside of our pyramid here. So again, for today, the concept is the same. We have some slightly different formulas relative to prisms and cylinders. But again, if we are taking careful notes here and applying it in the correct way, the general idea hasn't changed over the last 3 lessons. So take this time, ask questions if and when you have them, go through some practice problems, and honestly, just like usual,